Alright, so in this problem, looking at trying to understand the relationship between diameter and circumference, first thing it says to do is to use your centimeter tool, measure the circumference and the diameter of each of these shapes. So I'm going to go through and measure each of these, and then I'll come back. So let's use that tool, click on the edges of my circles, get all those measurements. Um, and what I'm going to do here now is I'm going to use my move tool and move everything so it's a little bit out of, so it's not all on top of each other. And I can tell the difference between my circles, my measurements, and where everything is. So now it says to actually take the calculator. So I've got my calculator over here and divide each of my numbers. So I have 12 and 57 hundredths, and the diameter there was 4. 3 and 4, 1,425, 10,000. So let's see what happens to the other one. 18 and 85 hundredths divided by 6. Oh, that's pretty close too. How about 21 and 99 hundredths divided by 7? All these numbers are really close together. And what do they look like they're really close to? Well, there's an approximation that we use often that this should look really familiar to. Now, they're not all exact, and that has to do with our rounding, the fact that all of these values for the circumference are rounded 2 decimal places. So we see that they all start, though, 3.14, and then there are other changes based on the decimal approximations. 3.14 should click in your head. Oh, that's pi. That's that relationship. So what pi represents is the relationship between the circumference and the diameter, where that it's telling me how many times, if I divide the circumference by diameter, how many times does it create? It always creates this constant. And that constant pi is an irrational number. It goes on forever and it never repeats a pattern. Now let's see. The second part here says, what happens if we change to 4 decimal places? So it says go down here to settings, and instead of 2 decimal places, we're going to change this to 4 decimal places. Close this, and let's just go through and remeasure everything. So I'm going to click on those circumference. You see it gets me a little bit better. You can see all these measurements become a little more exact. And I can't see that last one, so I'm going to move this one over, and I'm going to see if I can pull it over. Oh, looks like the fourth one just doesn't want to come. But we can do the other 3, and we can check them out and see. So now we have 12 and 5,664, 10,000s divided by 4. Well, that's a little bit more exact. Let's say 18 and 8,496 divided by 6. And then 21 and 9,911 divided by 7. Look at all 3 of those. They become even closer together. 3.1416, 2 of the 3 do. The other one's 158. And if you look at what exactly pi is, they'll continue to get closer and closer the more decimal places that you provide. So the more information you give it, the more exact your solutions will become, just because you're becoming more precise with your values.